Now we're recording. Okay. So we are going to continue our journey through substitution of definite integrals. So let's start with this problem here. Integral from 0 to 1 of x squared cosine of pi over 2 x cubed. So I'd like to have some input here, or I would like to see you work on this yourselves too. And what do you think the u should be? Pi over 2x cubed. So good. If we say u equals pi over 2 x cubed, what's our du?
X squared cosine.
So just think about, this is our u. So pi over 2 is a coefficient, and then we have x cubed. So it's the derivative of x cubed.
3x
Times 3x squared. Or we can write that as 3 pi over 2 times x squared. And if you notice over here, we have an x squared. We don't have the 3 pi over 2. So we would say 2 over 3 pi du equals, I forgot my dx, equals x squared dx. So that this becomes, we would consider the 0 to 1 of cosine of pi over 2 x squared x cubed that x squared dx. And this part here, bless you, becomes our 2 over 3 pi dx or du. And we can start making our substitution now. So we'd have another integral. We're going to have to change the limits of integration, so we get to figure that out. And now it's going to be a cosine of u du, and I got to remember that 2 pi over 3, I'll put it out in front here. 2 over 3 pi, I should say. So what are those limits of integration going to be? Since u has been defined to be pi over 2 x cubed, I need to look at u defined at 1 and u defined at 0. So if I put 1 in there for the x, talking about this right here, it's pi over 2 times what? 1. So it's pi over 2. And then if I put 0 in there, it's pi over 2 times what? 0. And what is that? 0. So it's going to be the integral from 0 to pi over 2 of cosine u du. And I get that 2 over 3 pi out front. I get multiplied by whatever the result would be. So we've done, I'd say, 80% of the work. Now we've got to integrate a cosine. What's the antiderivative of a cosine? I think it's a regular sign, isn't it? Derivative of cosine is negative sign. The antiderivative sign. And I don't want to say, because last time you were right and I was wrong, but so I'm trying to like double check myself. Derivative sign is a positive cosine. So we have this 2 over 3 pi times sine of u from 0 to pi over 2. Okay, here's a big question. Who remembers their pre-calculus days? Their trig days? What's sine of pi over 2?
1.
It is 1. Very good. Sine of 0, what's that?
0.
Very good. So our answer is just going to be 2 over 3 pi. That's it. Okay, questions? Is that bad? We're gonna get the handle of this, and so let's get through a few sections and we'll look at that, the work you had there, David. You have it?
It's really nothing, it's just, I think it's a dumb question.
Okay. Okay, then let's go ahead and move on. Here's another one. Use substitution to evaluate integral from 0 to pi over 2 of cosine squared theta d theta. So this one's a little trickier in my opinion. In fact, I'll say it's a lot trickier because normally when we have a cosine inside as an inside function, because what this is saying, this is the integral from 0 to pi over 2 of cosine of theta squared d theta. So it's something squared, and that inside function is a cosine function. So, and I'm going to move a transform kind of back in a second. I mean, I can leave it like this, and what I'm going to do is make a substitution, and I'm going to really draw on your days of trigonometry. So there's some power reduction formulas. Remember the power reduction formulas from trig? How to go? Okay. When you're doing the homework, you may encounter the power reduction issues, so you might look up power reduction formulas. This uses a power reduction formula. Now, the reason we have to do that is because we don't have something outside. So like if we said u was cosine theta, du would be negative sine theta d theta. We don't have a sign anywhere. We can't just pull one out of thin air. That's the kind of the frustrating thing here. So we have to use the tools that we have available to us. And the one of the tools is a power reduction formula. So this power reduction formula says it's going to be integral from 0 to pi over 2 of 1 plus cosine of 2 theta over 2. So the way that one works, it's going to be 1 plus cosine of 2 times whatever the angle is divided by 2. So you end up with a double angle. So you may recall back in your pre-calc days, you have the half angle formulas that result in like in a square root. And then you have your power reduction formulas that doubled your angle. Or maybe not. I mean, I'm sure, I'm totally confident you've seen this before. It just may not be the first thing on your minds. There's one for sine and there's one for tangent as well. So I believe the sine one is, and I hesitate to even do this because someone's going to say, you got it wrong. It's going to be 1 minus cosine of 2 theta over 2. And then the tangent squared theta is going to be, I believe it's 1 minus cosine 2 theta over 1 plus cosine 2 theta. I could just do a quick little search on my phone and find out. And there. Yeah, that's correct. So sine becomes a 1 minus cosine 2 theta over 2. Cosine is 1 plus cosine 2 theta over 2. Tangent is the 1 minus sine over the 1 minus cosine 2 theta over 1 plus, because it's sine over cosine. And then you can get the inverse, the other reciprocal functions from there if you want to. Okay. So that's just a side note. Remember that for your homework. Now we can split this up. So it looks bad and it is a fraction. I know nobody likes fractions. So the integral from 0 to pi over 2 of 1/2 plus cosine of 2 theta over 2 d theta. And we can treat these as separate entities. I mean, we can treat this as the integral from 0 to pi over 2 of 1/2 d theta plus the integral from 0 to pi over 2 of basically 1/2 of cosine of 2 theta d theta. And the first one is a straightforward integration. Nothing has to happen that's unique there. It's just a constant being integrated. What happens when we integrate a constant? What do we get? Integrate integral 1 dx is just the x, right? So the first part is just going to become 1/2 theta from 0 to pi over 2. The second half is where the fun stuff begins. So here's where we'll say, okay, u equals 2 theta. That's the stuff inside the cosine. And what's the du going to be? What's the derivative of 2 theta? Anyone know what the derivative of 2 theta is? So I feel like you know this, but you're just afraid to say. So derivative of 2 times x, if we take with respect to x, is what? 2. So same thing for theta. Theta is just the variable. So it's 2 d theta. And we don't have a 2 d theta. We have a half. So I'm going to divide by 2 and say it's going to be 1/2 du equals d theta. Okay, so I can make this change now. So this is going to be plus. I'm going to change my limits of integration because I did this u equals 2 theta. I have the 1/2 that carries through from before. I have the 1/2 that's part of this 1/2 d theta. That's not, yes, du, excuse me. And then it's a cosine of u du. Now let me ask you this. If u equals 2 theta, what is u of pi over 2? That's going to be 2 times pi over 2. What's 2 times pi over 2? Pi. Okay, so the upper limit is pi. How about u of 0? That's 2 times 0. What is 2 times 0? 0, yeah. So we have, for the first part, 1/2 of that pi over 2 minus 0. For the second part, u.
Derivative of cosine u.
Yes,
Just sine.
sine, yeah. Sine of u from 0 to pi. So we're looking at sine of pi minus sine of 0. Anyone know what sine of pi is?
Zero.
It is 0. How about sine of 0?
Zero.
It is also 0. Good. So 1/4 of 0 minus 0. So it's pi over 4. Anyone know what what is 0 minus 0?
Zero.
It's funny because like in calculus, we've done so much stuff with like L'Hopital's rule and all that. Like, I'm not quite sure anymore what 0 minus 0 is. We have to take a limit, right? No, it is 0. Okay. So 1/4 of 0, 0. So the answer here is just pi over 4. That's it. What would you call the u in this case? X squared plus 2. Okay, good. So if our u is x squared plus 2, what's our du? 2x dx. And we have that, don't we? Or, oh, that's a tricky. Okay, they made a mistake. That should be an x there because they're not. If not, then they treat the whole thing as a constant. It would integrate to be 2x over x squared plus 2 cubed times t. But they're not doing that. Okay. Jeez, I just corrected it with their mistake. Okay, so that's going to be, here's our 2x dx. So it's going to be this integral of 1 over u cubed du. And just because I'm me, I'm going to do this as integral of u to the -3 du. And I forgot my limits of integration. So what is u of 1 going to be? And what is u of 0 going to be?
U1 is 3.
Yeah, it's 1 squared plus 2 is 3. And u of 0 is 0 squared plus 2 is 2. So the limits are going to go from 2 to 3. Are you okay with that? Okay, so if we integrate this, it's u to the, we add 1 to that power, what does it become? Add 1 to -3. -2, good, and we divide by -2, and we're going to evaluate that from 2 to 3. So if I can clean this up a little bit, it's going to be 1 over -2u squared evaluated from 2 to 3. Are we on the same track still? So it's going to be 1 over -2 times 3 squared minus 1 over -2 times 2 squared. So -2 times 3 times 9 is -18. And I have a double negative, so make that a plus. 1 over 2 times 4 is 8. So I guess we need a common denominator between 8 and 18. It came up with 72. It seems right. So we have to multiply this 8 by 9 over 9. And the by 4 over 4. So that's going to be -4 over 72 plus 9 over 72, and you get, good job, 5 over 72. I agree.